Well, hello to my SAT prep students. Let's start with a little warm-up today. Last class we learned about the trial and error test taking strategies, the last couple classes actually. And you might think that only a multiple choice question can be used with trial and error, but I'm going to show you today how you can use this trial and error method with grid-in or open-ended questions as well. But first, let's review. So here's your warm-up. It says if x minus 1 over 3 is equal to k and k is equal to 3, what is the value of x? Well, the first thing that you always do, if they give you information, and they do, right? They're giving you k is equal to 3. First thing you always want to do is plug in whatever they give you. So let's see, if we have x minus 1 over 3, that's the same thing as x minus 1 over 3 is equal to 3. So then you look at the end of the question. What is the value of x? All right, well, we're trying to find this x. So let's say you didn't know how to do the algebra. Let's do trial and error. So let's try. Now we're going to do trial and error. So we'll try A. Is 2 minus 1 over 3 equal to 3? Well, 2 minus 1 is 1, and 1/3 is certainly not equal to 3, so you can rule that out. Let's try B. Is 4 minus 1 divided by 3, is that equal to 3? Well, 4 minus 1 is 3, and 3 over 3 is equal to 1, and 1 does not equal 3, so you can rule B out. So let's try C. C is 9, so is 9 minus 1 divided by 3, is that equal to 3? Well, 9 minus 1 is 8, so 8/3 is not equal to 3. We're going to rule that out. So let's take a look at D. Is 10 minus 1 divided by 3, is that equal to 3? And yes, it is, right? Because 9 divided by 3 is 3, and 3 does equal 3. So that checks out. All right, let's test your memory a little bit of our last class. I told you it's important to understand what the math part of the exam is made up of and how long it is and what's allowed and what's not and all that. So take a minute right now, pause this video and see if you can fill in the blanks. Okay, so hopefully you paused it and at least filled in a couple of the ones that you knew. So there's two tests. One is a 25-minute test and another one is a 55-minute test. On the 25-minute, there's 20 questions. 15 of those questions are multiple choice, followed by the other 5, which are open-ended. We're going to talk about open-ended trial and error today. On the 55-minute test, there are 38 items. 8 are multiple choice, followed by, oops, not 8, 30. 30 are multiple choice, followed by 8 open-ended. So that makes 25. Sorry, that makes a total of the 20 items. What makes up, let's see. 58, sorry, 58 raw points. So it'd be 20 plus 38 total questions. Okay, so let's get on with the trial and error problems. We did one that is a multiple choice type problem for the warm-up. We're going to do one where they don't give you multiple choices, right? So remember my warning to you, don't feel guilty about using trial and error, even if you know how to do the algebra. Because remember, like in this problem, by substituting values in, we're actually checking the answer at the same time. Okay, so even if you know how to do the algebra, if they give you multiple choice and you can use trial and error, you should, because you will make fewer mistakes. Okay, so trial and error on grid in, which is the fancy word for it, but I'm talking about open-ended or non-multiple choice questions. So even when there's no answer choices, you can still use the trial and error method. You just have to be willing to go out on a limb and take a guess. Once you take a guess, you can run it in the numbers and figure out, is your guess too much or is it too little, right? So here we're going to read this problem carefully, figure out what it is they're asking for, and then we're going to guess at the answer and check it. So it says you have only dimes and quarters in your pocket, and there are 4 more dimes than quarters. If the total value of the coins is $3.55, how many quarters do you have? Well, let's take a wild guess. We're gonna start with, let's say there's 10 quarters. Okay. So you ask yourself, is it 10 quarters, right? And remember, they're asking us for the number of quarters. So is it 10? Well, let's see. If we had 10 quarters, a quarter's worth 25 cents. Plus, now remember, we have 4 more dimes than quarters. So if we have 10 quarters and we have 4 more dimes, we would have 14 dimes, and dimes are worth 10 cents. So if you add that up, you're going to get $3.90. $3.90 is more than $3.55, right? And your guess was 10. So if your guess went over in money, your next guess should be less than 10. So let's just say we guessed 8. So we're going to run the same scenario here. 0.25 is the worth, how much a quarter is worth. Plus, we're going to take that 8 and add 4 to it, right? Since there are 4 more dimes than quarters. So if you put this in your calculator, you would get only 320, which is less than $3.55 that you're supposed to get. So pause the video for a minute here and see if you can come up with what your next guess should be. Well, if our first guess of 10 was too much and our next guess of 8 was not enough, then we're going to go somewhere between 8 and 9. Of course, we're going to go to, or sorry, between 8 and 10, we're going to go to 9. So 9 quarters would be 9 times 0.25, and then we'd have 4 more than 9 dimes. 4 more than 9 quarters would be 9 plus 4 times the value of a dime. And guess what? That gives you $3.55. There we go. So we have how many quarters? Let's answer the question. How many quarters do we have? This was our guess, right? So you would say 9 quarters. Not too bad. All right, let me show you a couple of other examples. All right, example 2 says a rectangle's length is 3 times as long as its width. Let's do a little color coding with this one. the length of a rectangle is 3 times as long as its width. And then they also say that the area of the rectangle is 48. Then this is a two-part question, right? Because once you figure out what the length and the width are, this is how they try and trick you. The final question is, what is the perimeter? All right, so let's start with the red underlined area. Remember, this is trial and error. You're just going to kind of guess and check, right? So let's say width, length. And then let's look at what that would produce in area. So we're just going to guess. So let's see, that number, the area of the rectangle is 48. So two numbers multiply to give you 48. So you would pick numbers that would multiply to give you 48, right? But let's say you didn't realize that and just went ahead and guessed. Let's say the width was only 2. Well, if the width is 2, the length has to be 2 times 3, right? Or 6, which is length is equal to 3 times W. Well, if the length was 2 and the length, sorry, if the width was 2 and the length was 6, then the area has got to be 2 times 6, right? Or 12. Because area equals length times width. But that doesn't equal 48, right? So we can say that this does not work. All right, so let's see. 2 times 6 is 12. We need the area to be 48. So we need numbers that are bigger than 2 to start out with. So let's say 3. So if the width is 3, then the length must be 3 times 3, or 9. And then the area would be 3 times 9, or 27. Still too small. So your next guess is going to be bigger than 3. I'm going to say 4. So if the width is 4, then the length is 3 times 4, or 12. And then the area would be 4 times 12, which is 48. All right, so it looks like we have the right width, length, and area, since 4 times 12 does equal 48. But then they do this little tricky thing on you and ask you, always read before you answer a question, multiple choice or not. What are they asking you for? They're asking you for the perimeter of this rectangle. Perimeter is going to be 2 times the length plus 2 times the width. So let's fill in what we know. So the length is 12 and the width is 4. So you're just going to answer that question. So perimeter is 24 plus 8, which is equal to 32. So this is the answer to the question they're asking. You have to be careful that you're answering the question they're actually answering. Okay, so that's another example of a trial and error strategy being used on an SAT problem that is not multiple choice, or what we call grid-in. Here's another example. I'm going to point out some vocabulary to you here. They use this quite a bit, this word consecutive, on the SAT. So consecutive integers are integers that are next to each other. So for example, 1, 2, 3, right? Those are consecutive integers. Another term that they like to use is something like odd consecutive integers. If they said odd consecutive integers, then it would look like 1, 3, 5, 7, and so on. If it said even consecutive integers, it would be like 2, 4, 6, 8. Okay, so there's a little vocabulary. All right, so it says that another little thing I want to point out is this word is. That means equals, right? So something is equal to something else. So product of two consecutive integers. And they're talking about a larger and a smaller one. And what they want you to do is find the smaller one. Okay, so let's start out with, here's a smaller number and here's a larger number. Okay, so let's start out with a small number, like let's say 2. The consecutive integer that would go with 2 would be the number that comes consecutively after that. So if you pick the smaller number to be 2, the larger number must be 3. Then they say that the product is going to be 15 more than the larger of the two integers. So let's see, 15 plus larger. So what are they saying? The product is 15 more than the larger. So what we're looking for is for the product to equal that column. All right, so the product of 3 and 2 is 6, right? Product means multiplication. So 2 times 3 is 6. And now we're just going to list whatever the larger number is plus 15. So the larger number is 3. So we have 15 plus 3, which equals 18. We can say that 6 is not equal to 18. So we haven't come about the right number. And notice the difference between 6 and 18. Right? 18 is bigger than 6. So our next guess should be larger than our last guess, which was 2. So let's try 3. So 3 and 4 would be 2 consecutive integers. The product of 3 and 4 would be 3 times 4, which is equal to 12. And the larger number in this scenario would be 4. So 15 plus 4 is equal to 19. 19 does not equal 12. But we're getting closer, right? We're getting closer to, the numbers are getting closer together. So I think we're on the right track. We're just going to try a bigger number. So if the smaller number is 4, the next consecutive number would be 5. And the product of the two would be 4 times 5, which is 20. Now let's look at the larger number of the two, which is 5, and add 15 to it, and you get 20. So these two are equal to each other. So it makes the original statement true. So now we don't want to answer 20 in this case, right? We want to go back to what is it they're asking us in the question. Find the smaller of the two integers. So your answer here would be the smaller integer is that number that made the scenario that they're asking you for true, right? It made the product of 4 and 5 equal to 15 more than the larger integer. So the smaller integer is 4. So again, another example of a problem that you can do by using the trial and error method, even though there are no multiple choice answers to check. All right, this next problem takes a little bit of diagramming. And it is a method of trial and error. So first, team A has 15 boys and 3 girls. We're actually going to write that down so that we can model what's happening. And how many girls does it have? It has 7 girls. Oh, no, 3 girls. Sorry. I was reading from the other problem. 15 boys and 3 girls. All right. Team B has 5 boys and 7 girls. Okay, so the 2 teams trade players. Team A sending boys to Team T, while Team B sends an equal number of girls back to Team A, until the ratio of boys to girls is the same. So that means they have equivalent fractions. So if we look at what we have now, we've got initially, we've got 15 to 3, and that ratio certainly doesn't equal 5 to 7, right? Those are not equal ratios. So what we want to do is we want to move some of the boys from one team to the other team and move some of the girls from one team to another team until we get a fraction that is equivalent. So let's try a move. Let's see. Remember, we don't have any answers. We're just going to try a move. All right, so here's my first attempt. Let's see. Let's say I move 3 of the boys from one team to the other team. And at the same time, let's say I move some of the girls. I move some of the girls from that team to this team. So if that happens, then I would have, on the blue team here, I would have, instead of 15 boys, I would have 11 boys. And instead of 3 girls, I would end up having 6 girls. Then on the red team, what I would have is I would, since I have more boys now, I would have 5 plus 3 or 8 boys now. And 4 girls. Well, 11 over 6 is certainly not equal to 8 over 4. So we're not done yet. All right, let's see. We're close though. 11 over 6 is almost like 12 over 6, right? 12 over 6 would work. All right, well, let's try. Did we count that right? No, this should be 12. So, yeah, I just counted that wrong. So 17 minus, yeah, sorry, not 17, 15 minus 3 boys would give you 12 boys. And in this case, I just kind of guessed at what to do, right? But right away, I did get the right ratio, right? 12 over 6 is equal to 2. And 8 over 4 is also equal to 2. So then, like in other problems, this is a two-part question. Now, if you didn't get the right amount of things right away, then you could just do some scenarios and just continue trying and error, use trial and error to try and find different moves. I just happened to grab 3 and 3 and got it on the first try, which could happen to you too. Okay, so here's that two-part question where they try and trick you, right? So the final question is a total of how many players will have changed? Well, you can look at it here. 3 players changed to the other team, and these 3 players changed, right? So 3 plus 3, or 6 players had to change team. So that's a good way to do it. You could also do each move one at a time, right? And see what the ratios are. We just happened to get lucky on this one. Okay, why don't you stop the video now and see what you can do with numbers 1 and 2. Something, try and set something up. All right, hopefully you had a chance to try those. Okay, it says 1/3 of a number. All right, let's figure out what that is. 1/3 of a number. 1/3 of a number. So 1/3 of a number. Well, that's the same thing as n over 3, right? Okay. There's that word again. We like that word because it tells us what we're trying to set up. Right? That's equals. So 1/3 of a number is equal to the square root of a number. Let's see. Square root of a number would be something like that. What is the number? So something equal to something else, right? Let me use black. All right, so let's try some numbers. We want n over 3 equal to the square root of n. So let's try all right, so let's see, what is my first guess? Let's guess, I don't know, 2. Well, 2/3 is certainly not equal to the square root of 2 because the square root of 2 is equal to, let's use our calculator for this, second root 2, 1.41. So that doesn't work. So let's try, let's see, how far apart? 2/3 and 1.41. Not too far apart, so we're probably not too far off. So let's try another number. All right, so let's try a different number bigger this time. So let's try 3 over 3. Is that equal to the square root of 3? Well, 3 over 3 is just 1, right? And the square root of 3 is about equal to 1.73. So that doesn't work. Well, let's keep going. 4 over 3, is that equal to the square root of 4? Well, 4/3 is not equal to 2, right? So that doesn't work. All right, that's 4. Then I should notice here, wait a minute, the square root of a number. Let's try and get a whole number there. So let's try and use perfect squares. So because here when we did the square root of 4, we got a whole number, right? So let's see if that's the pattern that they're looking for. What if we did 9, which is a perfect square? is that equal to the square root of 9? Well, square root of 9 is 3. 9 divided by 3 is 3, right? So this checks out. All right, now we're going to go back to our question. What is the number? What is the number? So our number was n, right? And that's where we were substituting the 2, the 3, the 4, and the 9. So the number is 9. Since if you divide it by 3, you get 3, and if you take the square root of 9, you get 3. All right, let's see how you did on this one. Given that 2 to the x power and then raised to the x power again, then there's that second question, right? This is a two-part question. What's the value of 2 to the x? We have to figure out what x is, right? So this is an easier problem than you would think. So 2 to some power raised again to that same power is going to be equal to 512. So let's see, let's try, I don't know, let's try 2. So let's see, 2 squared is 4, and 4 squared is 16, and 16 is certainly not equal to 512. All right, let's try another number. Now you have to be careful. You would think that because 16 and 512 are so far apart, exponentials are supposed to be really big. So you could go from a small number to a very big number. So I'm going to stay low numbers. So I'm going to go to the next number. Let's say 2 to the third raised to the third. Does that equal 512? So now I'm going to try a different number. I'm going to go just a little bit up because I know about exponentials. They can rapidly increase, right? So 2 to the third power is 8. And 8 to the third power, if you put that in your calculator, is 512. So remember, they're asking you here, tricky question, what's the value of 2 to the x power, right? So 2 to the x power is equal to 2. We used our 3, right, for x. So it would be 2 to the third power, which is equal to 8. So you have to be careful. You always want to answer the last, make sure you're answering the question they're asking you, even though we had to find out what x was to answer that second part of the question. All right, here's that consecutive word again. So if you have consecutive even integers, right, where before our consecutive numbers would be like 2 and 3, consecutive even integers would be like let's say 8 and 10, right? Those are consecutive even integers, right? 12, so on. Okay, so they're saying that a certain number of consecutive even integers is 5 more. There's that is, we like that because that tells us where the equal sign should go. So the average of a certain number of consecutive even integers is 5 more than the first of them. Find n. So let's try. Let's say n is equal to 5. So I'm going to do the easy consecutive integers. So let's say there are 5 terms, so I'd have 2, 4, 6, 8, and 10. Well, if we add them all up, we'd get 30. But you know how to find the average. Average is the number of numbers, or sorry, the sum divided by the number of numbers. So this would be 30 over 5, or 6. All right, so we did the math. Now we have to see if it works. So the average, which is 6, is supposed to be equal to 5 more than the first of them. So 5 more than the first. 5 more than the first. Well, the first number is 2, which is equal to 7, right? So the average is not equal to 5 more than the first. So you're going to try a different number of consecutive even numbers. So let's try that instead of 5 numbers that you're adding up, let's try 6. So let's say 2, 4, 6, 8, 10, and 12 this time. So there's 6 numbers. So the sum, if you added all those numbers up, would be 42. And the average would be 42 divided by 6, which is equal to 7. 5 more than the first, again, would be 5 more than the first number in this series was 2, and that is equal to 7. So remember what's supposed to be equal, right? The average is supposed to be equal to 5 more than the first number you chose. So that's true, right? Now let's ask us what let's go back and say, what are they asking us for? They want you to find what n was. Well, here it is right here. When you had n numbers that you added up and took the average of, that's going to end up being 5 more than the first number in the series. Now, by the way, this would work for any numbers. You could have started with 4, 6, 8, 10. You don't necessarily have to start with the smallest one, but I did just to keep the numbers small. All right, that's it. You have a little exit ticket. Good luck on that. If you have any questions, just send me an email and we'll set up a meeting. Thanks, guys.